Volumetric analysis is a quantitative technique that involves acid-base analysis. It involves the determination of the volume of a standardized solution that is required to react with a substance. It requires that one solution must have an accurately known concentration. This is called the primary standard. The primary standard is prepared using chemicals that are pure and which satisfy a number of criteria. It must have a high level of purity, have an accurately known composition, be free of moisture, be stable and unaffected by air during weighing, be readily soluble in pure or distilled water. It must have a high molar weight solid to reduce the percentage error in weighing, and it must react instantaneously and completely. A substance that fits all these criteria is anhydrous sodium carbonate. It is a white solid that is dried at 150 to 180 degrees Celsius in a drying oven for 30 minutes, and then cooled in a desiccator containing drying crystals. This solid is kept in a sealed container. Approximately 2 grams is weighed into a clean and dry beaker on an electronic balance. However, it does not have to have this exact mass, as long as the weighed mass is known to approximately 3 decimal places. Using a plastic wash bottle, add around 20 milliliters of distilled water to the beaker and stir. Using a stirring rod, stir the mixture to dissolve the solid, ensuring that the rod is in the beaker at all times, and that the solid is completely dissolved. Before transferring the solution into a 250 ml volumetric flask, ensure that it is pre-cleaned and rinsed with distilled water. The flask does not have to be dry, as more water will be added later. Using a clean glass funnel, transfer the sodium carbonate solution using the stirring rod to guide the solution and prevent splashing. Use the wash bottle to carefully ensure all of the sodium carbonate solution is transferred. This can be achieved through rinsing the beaker thoroughly many times and adding all the washing to the volumetric flask. Rinse the rod and funnel with the wash bottle and ensure all rinsings go into the flask. Add distilled water to the volumetric flask until the water level in the flask is approximately 1 centimeter below the engraved mark on the flask. At this point, using a clean dropper, add distilled water drop by drop until the bottom of the meniscus is in line with the engraved line. Avoid parallax error by reading the meniscus at eye level. Stopper the flask and invert 4 to 5 times to thoroughly mix the contents. Once the standard sodium carbonate solution has been prepared, it can now be used to analyze the unknown hydrochloric acid. Through knowing the exact mass of the sodium carbonate allows us to find the number of moles. This in turn can be used to find the moles of hydrochloric acid, which will be useful after the titration is complete. The first step that must be taken is the preparation and filling of the burette. A burette is an accurate piece of volumetric glassware that has markings from 0 to 50 ml with 0.1 ml divisions. Before use, the burette must be cleaned and rinsed with distilled water. Ensuring that the tap is closed, fill the burette with water and allow a small amount to run through the tip to ensure that the space below the tap is also clean. Close the tap and roll, allowing rinsing of the whole burette. Discard the washings and complete the rinsing process several times. Once the rinsing with distilled water is complete, small amounts of the hydrochloric acid are then used to rinse the burette thoroughly using the same technique as used with the water. These washings must also be discarded. The burette is then clamped onto the retort stand using a burette clamp. A small clean plastic funnel, plastic must be used as the glass tip of the funnel may break easily, to fill the burette with unknown hydrochloric acid. Fill the burette above the zero line and open the tap slowly to let the acid run into a wastebasket until the base of the meniscus is on the zero line. When filling the burette, either hold it or ensure that it is safely secured in the burette clamp. Always wear goggles and ensure that it is being poured in at eye level so that none of the acid can spill or splash into eyes. Ensure that the acid has filled the space below the tap and that there are no bubbles present. The substance that fills the burette is called the titrant. The next step that must be taken is the preparation of the pipette and transferring the standard base into the conical flask. A bulb pipette only has one engraved line and is an accurate piece of volumetric glassware. During this titration, we will use a 20 ml pipette. A pipette filler is used to draw up some water to rinse the pipette using the same techniques as the burette, where you must roll the water to ensure the whole pipette is rinsed. Next, the pipette must be rinsed with small amounts of the sodium carbonate solution, discarding all the washings. After the pipette has been rinsed with both distilled water and the sodium carbonate solution, it can then be filled with the sodium carbonate solution. Ensure that the bottom of the meniscus is on the engraved line. The conical flask is the reaction vessel. It must be thoroughly cleaned and rinsed with water. It can be left wet as more water will be added during the titration. The sodium carbonate that is now in the 20 mm pipette can be transferred to the conical flask. The solution is allowed to drain under the force of gravity into the flask. The tip of the pipette should rest against the inside glass of the flask so that the adhesive forces ensure that the liquid is fully transferred into the flask. There should always be a remaining drop in the pipette as this has been accounted for by the manufacturer, so do not shake or try to blow it out. The reaction that takes place in a titration involves the neutralization of sodium carbonate solution and hydrochloric acid. These solutions are colorless, so a suitable indicator must be used. In this case, 3 drops of methyl red is added to the conical flask. The solution will be yellow as the solution is basic and will change color to pink in an acidic solution. Place the conical flask on a white tile under the burette that is full of the unknown hydrochloric acid. Open the tap and add acid slowly. Use the other hand to swirl the flask to mix the solution that is being added. If any of the solution splashes up the sides of the conical flask, use the wash bottle to rinse it down into the reaction mixture. Continue to add the acid until the point where the reaction mixture changes color. This is called the end point. Record this volume and use it as the rough, as the exact end point may have been missed. This volume can be used as an approximate endpoint so the subsequent titrations you can approach to the endpoint. Refill the burette and pipette to prepare for the next 2 to 3 titrations. Repeat the titrations, but as you get closer to the approximate endpoint, restrict the flow of the hydrochloric acid so it enters the reaction mixture drop by drop. The wash bottle may also be used once again to transfer drops of the hydrochloric acid from the burette tip. After 2 to 3 titrations have been completed and the volume has been recorded, find the average titration volume of the acid to further work out the concentration of hydrochloric acid. Once the volume is known, the moles of the hydrochloric acid that was found earlier in the process can be used in the equation concentration equals moles divided by the volume to find the unknown concentration of hydrochloric acid.